Okay, hello guys, I now welcome you with the second part of my video, which is all about aircraft designing, the stability and control, and which is the first video was about the lecture and demonstrated by Professor Dr. A.K. Ghosh from Indian Institute of Technology, which is from Kanpur, and it was the lecture is transcribed, and I have actually presented or actually explained or rephrased what was actually done by Professor, and I just want to actually complete the second half of the video by completing the rest of the pages especially produced for the lecture. So we have covered some of the technical parts, especially the controls, the three types of controls. We have also covered the LD ratio as well. We have explained how the LD ratio will going to impact the usage of fuel, and also going to impact the latitude, and also the width as well. They are different. You can actually check the LD ratio and you can get the idea. So we have also discussed the attack, angle of attack. We have also discussed the main parts through which we are able to let you know about what was the important dynamic stability, and the static stability was also discussed, and all the key concepts will also be explained in our rest of the videos or coming videos as well, especially from this institute, because we are actually willing to complete the specific course by completing or actually just presenting the different lectures from presented by especially by Professor, and introducing the different key concepts. So just to give an introductory idea about what is the stability and control, I have actually opted in to reproduce or represent this video, which already been explained by Professor A.K. Ghosh, and I'll let you know about I draw this line, this is the ball. Now what happens? It must excite your mind to go back to your class 10th, 11th, where these diagrams are frequently used. Let's say this body is in equilibrium. This dotted line show the equilibrium position. Okay, when is the meaning of the equilibrium? The net force and its moment are zero, right? We have discussed in physics that what is what is actually the meaning of the equilibrium when it is the force and the moments are zero. So that is why the power point is said to be at equilibrium. The similar case, if I have come through aircraft, this is the aircraft. One of the equilibrium state is on the airplane is in cruise, okay, where lift is equal to weight, thrust is equal to drag, net force is zero, net moment is zero. So cruise is also in equilibrium state. Now what is the question you are going to address? You are going to address whether this body at this equilibrium is statically stable or not, meaning thereby if I come again from here to here, if I have the same question. Okay, let me do once more, read it once more. One of the equilibrium state is on the airplane is in the cruise, okay, where lift is equal to weight, okay, and thrust is equal to drag. Yes, this is the LD ratio. The net force is zero, net moment is zero. The state is called the equilibrium state. So the cruise is also in equilibrium state. Okay. The equilibrium. The professor is discussing the equilibrium state of an aeroplane when it's on the cruise. So obviously at the cruise, it's very easy to explain the equilibrium position of any object on a cruise. So what is the question you are going to address? You're going to address whether this body at this equilibrium is statically stable or not, meaning thereby if I come again from here to here, if I have the same equation. Yes, that is the question. Now the further question is that whether it is statically stable or not. So just getting the whole it's the LD ratio, and also the it is the weight and also the drag. Yes, this body is in equilibrium here because net force is 0 whether this body is in body statically stable or not. How do I check? I say I give a small disturbance. Okay, the moment I disturb it from the equilibrium state, you see there is a component of weight you will be there which would try to take it back to the equilibrium state. So it has initial tendency to take the body toward the equilibrium state. The catchword is initial tendency. So we say this body is statically stable mode or statically a stable condition. Okay. Yes, the catchword is initial tendency. You have to test it whether it is in equilibrium or in static, whether it is it's statically equilibrium is in equilibrium or not. So that is the question. In contrast, if you say this body here, if I displace it by a small amount, now the component of weight will take it away from the equilibrium state. Okay, displacing it with a small amount. So we say it does not have any initial tendency to come back to equilibrium. So this is statically unstable. This is clear. So this is statically unstable. This is clear. Similarly, with this understanding, if I try to know whether the gentleman or friend aircraft is statically stable or not, what we have to do, we have to first see what is the equilibrium state, because static stability we are talking with reference to the equilibrium, a disturbance about the equilibrium. Okay, a disturbance about the equilibrium. And okay, so first we find out equilibrium state. Here I know the cruise were lift. So first we find out equilibrium state. Here I know the cruise where lift is equal to weight, thrust is equal to drag, and moments are automatically balanced. This is typically a equilibrium state. And now what if I want to check whether this is static stability or not, satisfying static stability condition or not, what I have to do, I have to give it some disturbance as delta alpha. Angle of attack will be an upward gust coming like this, and if it immediately generates a moment nose down, that is to nullify. Okay, that is all explaining the state of equilibrium, and also in static mode as well. So I'll able to actually explain it further when I'm going to actually get in some other details of this further courses. I will able to explain it better. And this delta alpha, because initially the equilibrium state was, let's say, alpha 2 degree, and because of the disturbance, let's say, angle of attack became 3 degrees. So static stability demands that it should automatically here it is nose down moment. So that is so that is has the initial tendency to come back to 2 degree of alpha. Is it clear? Okay. If it is statically stable. If it does not, it is statically unstable. At this point, please understand, it is not that we cannot control statically unstable airplane. It is not that we cannot control statically unstable airplane. Okay, the catch statement is unstable does not mean uncontrollable. You can do an experiment. You can take a stick on your finger. Imagine a stick is there that's statically unstable, but you can control it. Okay, in fact, most of your fighter airplane are that are marginally stable or marginally unstable in terms of static stability sense. That is why they are highly maneuverable. Okay, once you do that static stability, we will be spending a lot of time on dynamic stability. That is okay, fine. So we understand that suppose I make a mass spring system, right, and assume that this whole mass spring system is isolated from the environment, and the spring is linear, there is no air. Okay, that is here. If I draw the free body diagram, I will find mg acting here, and here the force, because of extension case, they are balanced, so it is at equilibrium. Okay, dynamic stability. Okay, the mass, and this it is the coefficient, I believe. K is the coefficient. It is an equilibrium. Ky and mg. Now if I want to check whether this body is statically stable or not, what I have to do, let's say I stretch it here to some length and then release it. So what will happen the moment I release it? Because there will be a force kx acting opposite, so it will start moving towards the equilibrium. It will overshoot. Again, as it overshoots, the force will be acting downwards, so it will again take it like this. So it will go on accelerating like this, and since there are no air, no medium, a spring is linear, it will keep on oscillating like this. Absolutely right. So do you call it statically stable or not? Let us check from the equilibrium. Where I deflected the body, it has tendency to come back to the equilibrium. So it has initial tendency to come back to the equilibrium, but because of inertia it goes up and again as it goes away from the equilibrium. It has the tendency to come back to this, so it goes on low. Obviously inertia is the problem. Inertia, because of the inertia, it will not going to stop. It will just it will keep on oscillating from one point to another, and that will keep on going. So it does have static stability, but does that mean it has dynamic stability? If you want to know what is dynamic stability, we have to put another condition here. Not only the initial tendency to come back to equilibrium, but also its amplitude should become fine air time, that it should go on doing like this, and finally it should come here to equilibrium. So this will not happen here. This is the case where it is statically stable but dynamically not stable. Okay, so this will not happen here. This is the case where it is statically stable but dynamically unstable. Okay, now think of a situation. If I put some water or oil into this, what will happen? It will have this, and amplitude will come down, so there is damping. And for dynamic stability, not only the initial tendency, its amplitude should become fine air time. So there will be concept of stiffness. There will be a concept of damping when you are talking about dynamic stability. Okay, so the stiffness and damping are the two related concepts related to the dynamic stability. So we have to keep that in mind. Okay. I'll just give the technical definition of damping. It primarily relates to acceleration. That's what I know of. Damping is any effect that tends to reduce the amplitude of variation in mechanics. The internal friction may be one of the causes of such damping effect. Yes. Damping effect is this. Damping is any effect that tends to reduce the amplitude of vibrations. What causes damping? Okay, damping of oscillation, a decrease in intensity of oscillation with time caused by energy losses in the oscillatory system. The simplest case of energy loss for an oscillation is the conversion of energy into heat as a result of friction in mechanical systems and of resistance in electrical systems. Okay. What is damping and its types? There are many types of mechanical damping. Friction also in context or Coulomb damping arises chiefly from the electrostatic forces of attraction between the sliding surfaces and converts mechanical energy of motion or kinetic energy into heat. Okay. So now think of a situation. I've put some water or oil into this. What will happen? It will have this, and amplitude will come down, so there is damping. And for dynamic stability, not only the initial tendency, its amplitude also should become fine air time. So there will be concept of stiffness, there will be a concept of damping when you are talking about dynamic stability, right? Okay. and this damping decides the passenger comfort or the handling qualities of the pilot. So we see how they can get connected. So we will be talking more and more on the dynamic stability in this course. Yes, I've gone some of the topics and titles, so it is in the future videos as well, so we can get the explanation in detail about dynamic stability or vis-a-vis static, because there will be many students who will be joining this course. Okay, do not have the first course exposure, even if they have, if anybody want time, so it's my duty to see. Okay, let's say it's flying at some speed. We have seen whether it is statically stable or not, dynamically stable or not. Once we have done that, then we will try to know if I give the unit deflection of elevator, how the angle of attack is building, right? Whether it is building something like this or something, or building something like this or building something like this. Okay, his professor is actually on the board and it's explaining the things, and it's just the slide is referring to the slide as well. So in this diagram 3, I have shown that they are all finally coming to some angle, let's say alpha star. But these 3 graphs also tells us that transients of going to that alpha star is different. So we have to clearly see how do I calculate alpha star, that the response for a deflection of elevator in that domain, right, with time, how it is happening. So this is also extremely important topic that we will be discussing in this course. So you should see that initial few 8 to 10 lectures will be exactly what we have done in our last course. In some same video clips will be showing to you. I will be coming again after 2 or 3 lectures as a month-bath session and try to discuss few things more, because there will be many students who might not done airplane performance. Even if they have done, they have missed few concepts. But once we have built a solid base, then we go systematically into static stability. What are the control required, the dynamic stability part, response, and how do I design the handling qualities. So this will cover the whole course, which is a huge course. Please understand, obviously it is a very huge course. It is not a simple, I'm just getting through the slides. That's not the point. I have to actually explain it once more, again and again. Even if please I recommend that you should actually comment as much on the topic, so that eventually there is a solid understanding and solid ground of actually getting our understanding better and better. So that is why the aircrafting and the designing is very crucial, because each bit, each part is so technical and so sensitive that we have to take care with zero tolerance level. There is no tolerance as far as the engineering perspective is concerned, designing perspective is concerned, or any other actually field is concerned, especially related to the aircraft. So please comment, and please let us know what are some of the flaws that you see that we are getting, even if we are explaining altogether the words from the professor's mouth. So I will be using Laplace transform, which I will explain. Don't panic about all these names. I will ensure and get guarantee that will be yes. Laplace transform is actually a mathematical concept. So I believe it's a series. Laplace series. It is a series. Mathematical series, and it has altogether a formula as well, a defined formula named after a scientist. So we'll obviously go as our professor will going to teach us, and will help to gain the understanding. So this with that positive note, we will take up this course. I hope you will enjoy, and this time for us a change. You will be allowed to interact with me directly on question sessions through my another email ID I will be creating, and I would like to interact with you directly along with the TS right. So that helps something. Sometimes there is a lag, which I learned from last course. Thank you. So obviously I'll be connecting, not right now, but obviously when we are in a position to get our sound understanding about the aircrafting, especially with the basics, we can go to a professor or any related personnel, especially to this field, so that we can get the exact information when we are dealing with the commercial point of view as well, especially because all the things end up in a commercial and in a sales and a marketing point of view as well. So that is, but the understanding, the key concepts needs to be clarified with sound basis and sound root. So I'll be hoping for your comments. I'll hoping for your more questions to be raised in the comment section, and that will help us to build our understanding even to a more advanced level. So in this video, it is an introductory video, as I said, the second part of aircraft stability and control by Professor Dr. A.K. Ghosh from Institute of Information Technology, Kanpur, and I have gone through some of the basic details about the from the tail to the mid part of the airplane, just getting some of the basic controls. So, and also explaining the key concept. Okay, so what was the angle of attack, what was the LD ratio. So later professor has also explained some of the further concepts in this video as well. So I hope to see you with some other interesting part, and obviously with the next part of this course, and hope to see you to continuing with the same concept, obviously getting through one by one through different concepts. And even if we miss some concepts in this video, we'll try to cover in our later videos. Obviously the concepts do come again and again, so if it's been missed, we'll try to cover in the coming video so that we can connect all together and obviously get our firm understanding. So hope to see you with the next video. Thank you very much. Take care and have a nice day.